Positive charge comes from the protons inside the nucleus and negative charge comes from the electrons inside the nucleus. So, electrons carry negative charge, protons carry positive charge. Whether it is movement of a positive charge or negative charge, it will definitely produce current, and the current produced by the movement of positive charge is called as conventional current, and the current produced by the movement of negative charge is called as electronic current. Direction of conventional current is same as that of the movement of positive charge, but direction of electronic current is in the opposite direction of the movement of electrons. These things you should never forget. It is not only for now, it is for 2 years. In 12th, once again you will have the same chapter called as current electricity only. So, if you are failing to understand now, you will have problem in 12th also. So, become strong now itself. Then we learnt about the formula of current mathematically. I is equal to Q by T, where Q is in coulombs charges, T is time in seconds, coulomb per second is called as ampere. So, SI unit of current is amperes. We also learnt Q is equal to NE, which is total charge by N charged particles will be N times of basic elementary charge. Basic elementary charge is given by 1.6 times 10 to the power minus 19. Plus and minus indicates that it is produced by a positive charge or a negative charge. Then we have learnt about potential difference. Sai Darshan, video should be on. We have learnt about, I am teaching here, man. Yes. So, then we have learnt about, what you are seeing there? Potential difference. So, I said to you, if you want to move anything, forget about current, anything it has to move from one point to another point, we need a difference in potentials between the 2 points. So, to make the charge move from one point to another point, what you need? Potential difference. Who supplies that? A battery supplies that. So, battery provides the potential difference needed for the charge to move from one place to another. Mathematically, it is defined as work done per unit charge. Work done per unit charge to move it from one point to another point is called as potential difference. Work done will be in joules, charge will be in coulombs. So, joule per coulomb is called as volt. We have also learnt in the previous classes about the Ohm's law. Ohm's law relates potential difference and current. So, I have told you in a circuit, potential difference is always proportional to current. That is what Ohm said. If a conductor is following Ohm's law, then potential difference is always proportional to current. So, V proportional to I will make V is equal to R times I, which is the resistance. So, V is equal to IR is the formula of Ohm's law. From here you can see very clearly R is equal to V by I, V is in volts, I is in ampere, volt per ampere is ohms. This resistance graph is very important for the school examination. That is a straight line exhibiting V on the y axis, I on the x axis, and slope of VI graph gives resistance. I even told you, if there are 3-4 lines drawn, check which line is having greater slope, that wire will have greater resistance. This kind of question frequently come in MCQ, where they will draw 3 lines, they will draw a graph x and y and they will draw 3 lines. Revan sir, if Sai Darshan not on the video in 2 minutes, put him in waiting room. So, if there are 3 lines A, B and C, C has the maximum slope, then automatically it will have the maximum resistance. So, wire which has more slope will have more resistance. That is what the Ohm's law says. Ohm's law says that potential is proportional to current and that ratio V by I is called as resistance. This kind of questions are very common in the board exam itself. Then I have talked to you about factors on which the resistance is depending. There are 4 factors: length of conductor, area of cross section, nature of material and temperature. Again a very important part for this chapter for the board examination. So, I have told you R is proportional to L, I have told you R is inversely proportional to area of cross section, and I have told you R is also depending upon temperature. Different wires having different resistance is quite understandable by us. Copper wire, aluminum wire, gold wire, they will have different resistance, obviously. We can understand that. But why a longer wire has more resistance, shorter wire has less resistance? For that I told you that longer wire means more particles. More particles means more collision. Resistance from where it comes? It comes because of collision between the particles. If there are more collisions, more resistance. Less collision, less resistance. A longer wire has more charged particles. If it has more particles, then it will obviously have more chances of collision, and that is why it will have more resistance. A shorter wire has less charges, having less collision, having less resistance. So, that is why the longer wire has more resistance. Also, it is known that if area of cross section is increased, the resistance decreases. R is inversely proportional to area. Why is it so? Because if you have a bigger cross section, the electrons will have more space to move, less collision, less resistance. So, greater cross sectional area, lesser the resistance. That is what makes R proportional to L. R inversely proportional to area, combine it will become R proportional to L by A. If you remove proportionality, you have to add a constant. That constant is called as rho, resistivity. So, resistivity is R into A by L. Its unit will be ohm into meter square by meter. Meter will cancel with meter square, it will become ohm meter. So, SI unit of resistivity is ohm meters. The beautiful thing about resistivity is it does not depend upon length and area of cross section. That is why we classify the materials based upon resistivity. If you want to classify conductors from insulators, we classify them not by resistance, we classify them based upon their resistivity, because 1 meter of copper and 2 meter of copper will have different resistance, but 1 meter of copper, 2 meter of copper or 1000 meter of copper will have same resistivity, because resistivity is independent of length. That is the reason we use resistivity for classification of elements into conductors, insulators and semiconductors. Then I have taught you in the previous class about how do we connect resistance in series and parallel. In series connection, resistances are connected one after the other, and net resistance is summation of all the individual resistances. R1 plus R2 plus R3 plus R4 plus R5 plus R6 will give you total R. In parallel connection, on the other hand, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. What you should remember is, in series connection, the current remains same, potential gets divided, whereas in parallel connection, the potential remains same, the current gets divided. These things are very, very, very important. Current remaining same for series connection and voltage remaining same for parallel connection is a very deep concept. I also told you about heating effect of electric current, which was found by whom? It was found by Joule. What did Joule say? Joule said that, or Joule found the heating effect of electric current, where he found the value of heat energy as I square RT. This is what we derived in the previous class. I square RT, or you can convert into various forms like VIT or like V square by R into T. Like that we can write in various forms, but the concept remains the same, where this derivation has been done by the concept of V is equal to work done per unit charge. So, from where there we have derived, and in the previous class we could derive and we could find that heat energy produced by the current flowing in the wire is I square RT. I is the current, R is resistance, T is time. If you have doubt whether I will use I square RT formula or whether I will use V square by R into T formula, or whether I will use VIT formula, it totally depends upon whether what is given in the question. If you ask me whether V is proportional to R or inversely proportional to R, it totally depends upon whether current is constant or potential is constant. So, these clarity you will get when we solve some numericals today. Today our target is to solve the numericals. But before we go into the numerical, let us try to understand some of the applications of heating effect of current. So now we are in a mood to study what is the applications of heating effect. See, when we found heating effect, it was a trouble for us, because the wire which carries the current becoming hot. But later, after studying good about it by Joule, we made into our use. And today there are so many things we have in the market which are using heating effect of electric current to make that product itself. For example, you have bulb, but nowadays we don't use it much. But earlier we used to have this bulb called as tungsten bulb. Now we don't have tungsten bulb, but our syllabus is still in 1960s, so we have in syllabus. Nowadays we have what bulbs? We have LED bulbs, which works on different phenomena itself. It has diodes inside. But earlier, if you ask a grandfather or father, they would have seen this bulb. You would have not seen also this bulb in the home, because now we don't use this in, rarely we have. Some old thing is there, so it is kept. Otherwise we don't use this bulb. It takes too much power. This bulb is working on which phenomena? Heating effect of electricity. You know how this bulb works? Inside the bulb we have a tungsten wire. You may ask, why tungsten? Why not copper wire? Loudly? Good. We want something to have high melting point. Why is it so? Because heat will be produced. If it melts, circuit will break, then bulb will not glow.
It glows on heating.
That's what I am saying. It glows on heating, so it should have a tendency of having high melting point. That's why we choose tungsten as the material, because tungsten has high melting point. And how the bulb glows, you know? We have some inert gas inside the bulb. When this tungsten gets heated up, the heat energy is exciting the charges in the inert gas, and that glows to you and it looks like bulb is glowing. So basically the current passes through this tungsten, heats it up, and that heat is passed through the gases present in the bulb, and that gases only glows the bulb when it was used. So what we are having inside, we have inert gases like argon or something. We'll talk about that now. So always remember, write it down. Applications of heating effect of electric current. Applications of heating effect of electric current, and first application you write as electric bulb. And these are the important things. What should be the property of the filament? High resistance and high melting point. The tungsten of the bulb should have high resistance and high melting point. Why high resistance? Because only if it has high resistance, it will heat the wire. And why high melting point? Only if it has high melting point, it will not melt it down and break the circuit. So for bulb, we are using high resistance and high melting point material, which is tungsten. And what gas we use inside this? This is chemically inactive nitrogen and argon gas. This is the gas which is there inside the bulb, which glows up when heating effect is provided. This is called as electric bulb. One of the famous applications, not being used now, but it was used once upon a time very vigorously. Every home, the bulb will means this only will be there. Shall I go to the next application? Can you think about that? Second application, some other application of heating effect? Can you guess anything? Iron box, very good. Correct. Something else?
Heater.
Which heater? Geyser. Okay, geyser can be accepted. What else? What is that? That is also water heater only, no? Yeah, that is correct. Heating effect. And anything else? Think in your home what you are using. Geyser, heater is correct. Induction stove is
Electric iron.
electric iron, he told already. Induction stove, Prajin says. Induction stove is not using heating effect of electric current, Mr. Prajin. Induction stove is using magnetic effect of electric current. Okay? So we will talk about that some other day when we learn that chapter. Next chapter is that only, magnetic effects. But induction stove is the wrong example. Anything else which you know? Fuse, very good. They may ask this question in the examination, write any 4 applications of heating effect of electric current. Electric bulb, electric fuse, iron box, or what do you say? Electric and electric heater. 4, 2 marks given.
Sir, is oven counted?
Oven, microwave oven you are saying. Which oven you are saying?
The
If
electric oven,
el
not.
See, electric oven may be called for maybe application of heating effect of electric current, but not the microwave oven. Okay?
Yes, sir.
We use in bakeries electric oven. It will just heat the plate by the current. Microwave will be different. We have microwaves, electromagnetic radiation is there inside, and that microwaves are going and heating the thing and it becomes hot. That is different phenomena. It works on different phenomena. We'll learn all these things in higher classes. Chapter name is electromagnetic radiation. Okay. Next application, let us talk after bulb. Next application is electric iron, as told by Mr. Prajan. So, no need of drawing the diagram for sure, but you should just somewhere write what are the properties of that. So, once again we have a high resistance coil and we have mica sheet. Have you ever seen it opened? Iron box opened inside, it will have some mica sheet inside, brown color. Never seen it? Okay. Why mica sheet? Because mica sheet is a bad conductor of electricity and good conductor of heat. That's a special property of mica. Mica is having, it's a very poor conductor of electricity. Why we want that? Because current should not hit your hand, isn't it? You are holding it. Sometimes we touch the plates also. So, it should not, current should not pass to your body. So, we are using something which is having a very poor conduction of electricity. At the same time, it is a very good conductor of heat. So, we are using mica sheets inside the iron. So, other things are not much to be required to be written, but I hope you understand the purpose of it, how it works. Current comes, it heats the coil, isn't it? And if it heats the coil, the cloth is getting ironed by that. That's all the function is, nothing much. Inside we have a coil and current is passing, current will heat the coil, that's all. So, what two things to be remembering here is high resistance wire, obviously high melting point, and insulated mica sheet. Why? Because it will act as a good conductor of heat and bad conductor of electricity. Okay. Next comes, as told by Mr. Nitin, electric fuse. So, what is a fuse? I told in the last class also to you. Fuse is a safety device used at the entry point in your home. Entry point means where the current comes to your home. So, there we have a fuse wire which melts whenever excess current is coming. So, it is a protection device which is used to stop the flow of excess current in the circuit. And then this is how it is made up of. There is a porcelain body and we have a wire. Now, wire is of lead or tin which has a very low melting point and which has a high resistance. Remember that. We use a low melting point and a high resistance wire as a fuse. Why we want high resistance? Because current should pass slowly through it. Why we want low melting point? Because if it is excess current, it should melt. If it is not melting, then the excess current will go and will spoil the device, isn't it? So, remember, a fuse wire should have low melting point and high resistance. So, if the current is coming and if it is allowed current, it will pass through this wire. If it is not allowed current, it will melt, it will not go to this device. So, nowadays we do not use fuse for each part, but in our main supply we definitely use fuse wire still, where whatever current is coming from the supply, we make sure that it does not enter directly, it passes through the fuse before it enters the circuit, right. So, obviously fuse will have rating in the sense, you may say, you may understand that every appliance will not need same current, isn't it? Some appliance may need 5 ampere current, some may need 10 ampere current, some may need 20 ampere current. Like if you see in this room, bulbs are there, lights are there, they may need only 5 ampere current. This TV may need 10 ampere current, AC may need 25 ampere current. So, different appliances will need different amount of power inside. Now, if I want to put a fuse for that, that is light. And if I put a fuse of 20 ampere rating, then what will happen? Excess current will go inside, isn't it? If it is working at 5 ampere, then I can put some 6 ampere fuse. Are you getting what I am trying to say? Because if anything goes beyond 6, it will melt. Up to 6, it will allow to pass. Same way, if I am having a AC which works at 25 ampere, I should put a fuse which is having at least 26 ampere, 27 ampere capacity. If you put 10 ampere, what will happen? Before it works, it melts. Where AC will not work itself. I hope you get my point. So, we want to decide the fuse rating based upon the appliance we are going to use. Again, I am repeating, these things are not happening today, because today we have MCBs. Earlier, for each room, for each box, we used to have fuse, and for each appliance we will have fuse. TV behind there will be a fuse. Camera behind there will be a fuse. Fan will have a fuse. AC will have a fuse. Nowadays we don't have. But earlier each appliance will have its own fuse for safety. And that fuse is decided based upon its power consumption. If it is 3 ampere consuming device, we will give 5 ampere power rating. Now, fuse available in market will not be of all the ratings. Don't think 1 ampere, 2 ampere, 3 ampere like that. No. There are some available rating. Choose and buy for your appliances. So, I think they would have given here. I don't know whether they have mentioned that thing or not. Yes. 1, 2, 3, 4, 5, 10, etc. they wrote. But there are ratings available in the market. Like I want to get a 7 ampere rating, generally not available in the market. 1, 2, 3, 4, 5, then 10 and 10 only is available. So, that is one thing where you should suitably choose your fuse for a device. Question will be asked in the board examination. In that question, first you should find the current drawn, and based upon that you should recommend a fuse wire for the instrument. How will you determine that? You will find the current consumed first, and once you find the value of current consumed, you can give the little bit higher rating of fuse from there. We will see some questions now. So,
Sir, I have
yeah, please.
Sir, if they ask, sir, if the current for appliance is like 7 ampere, sir.
Yes.
But then the nearest rating is only 10 ampere.
Yes, you can give the nearest value of available rating. 10 ampere you can give.
Sir, then if it goes to like 10 ampere, the fuse won't break, but
You
the
may
appliance might get damaged.
that much allowance is there, man. If it is working at 7 ampere, till 9, 10 ampere it will take actually. Practically I am speaking to you. Okay?
Okay, sir.
Okay. So, now please guys, question is in front of you. Make it fast. Simple question first. Very simple question. What they have given here? They have given the energy, isn't it? Heat energy is given. R is given. They are asking you to find the value of V. The formula is known to you, right? V is equal to W by Q. Or check which formula will be used here. What formula will help you in finding the answer? Check fast. The question is in front of you. Solve it. Time is also given. 1 second. You have the formula of energy. Energy is equal to VIT, isn't it? Any answer? Did you solve it?
20 volt.
20 volt. 25 volt. Okay, let us check. 20 volt.
Sir, sir.
How much, Preetham?
20.
20.
Yes, sir.
H is equal to whatever. Then check how much answer you are getting. If we do that, yes, the answer is 20. Where you went wrong, you check, Jivitesh. The formula of heat energy is V square by R into T, and V is known here, R is known here, and T is known here. T is 1 second. So from here you have to find the value of V. If you solve correctly and get the answer, answer comes as 20 volt. Anybody has problem in this? Based upon what is the given data, you can decide what formula to be used. Don't think why I not use I square RT, because I is not given here, isn't it? What is given, based upon that only you should use the formula. If they would have asked you find the current, then I should use I square RT formula, isn't it? So please be careful about solving. Next question, fast. Next question in front of you. Don't take much time, solve it fast. Is it clear to you? What is the answer you are getting? Make it fast. They are giving the value of charge to you. Time to use 1 hour. Time should be converted in seconds, don't forget that. Time is given, charge is given, V is given. You want to find the value of H. So what are you going to use? Which formula? Which formula are you going to use? VIT. Okay, V is known. I is how much? Q by T. Where is I known? I is not known here. Charge is only known. But one thing, time will get cancelled, isn't it? H is equal to VIT. V is equal to what? 50 volt. I is equal to what? Q by T. So if it is Q by T, TT gets cancelled. We get Q. Q is given to you. 480 kilojoules is the answer by Nitin Raghav. Let us check whether the answer is right or not. So when you solve it, then the answer is coming as 480 kilojoules correct. 480 kilojoule is correct. Don't just have a tendency of copying from here. Understand how I have solved. V is known, charge is known, and heat energy is asked to find. H is equal to V into I into T, and I is equal to Q by T. TT gets cancelled. V and Q needs to be multiplied. If you multiply these two, you are going to get 48 and how many zeros? Imagine 5 zeros will be there. So 48 into 10 to the power 5 joules. That is the answer. Did you understand what I did now? The formula of H is VIT. I is equal to Q by T. TT gets cancelled. Just multiply V and Q. Leave what they have done. They have done a lengthy method. Simplest method is H is equal to VIT. I is equal to Q by T. TT gets cancelled. V into Q will give me H. V is known. Q is known. Multiply both, get the answer. Nothing else is required. They have taken a very long route to solve. Leave what they have solved. Any problem in this question? Next question, make it fast. Next question, guys, fast. Let us do it fast, please. Then only you can solve many questions. Take it fast. Resistance given, current given, Potential difference you have to find, and also the heat you have to find in 30 seconds. Make it fast.
Voltage after volts, heat is 15 kilojoule.
Voltage is equal to?
100 volts.
Okay.
Heat is 15 kilojoule.
15 kilojoule.
Sir, how to express the units, sir? Kilojoules?
Anything will give you marks. Joule, kilo, mega, anything will give you marks. Mega avoid in 10 standard. They don't use mega in school.
That's million, no, sir?
Yeah, 10 power 6 million only, or mega, whatever you call it. Have you got the answer? So R is given here, I is given here, V is asked to find. V is equal to what? IR. 20 into 5, 100 is the answer for the first part, simple. And heat developed, H is equal to VIT. V is known, I is known, T is known. Just multiplication, nothing else. If you are good in that, you can easily solve. And the answer is 100 volt. For H, it will become equal to 15,000 joules. This is in significant figures. That is the correct way of representing the answer. Yeah, scientific. Shall I proceed further? Again, I am repeating, don't try to copy from the board what they have done by their own way. You do by your own way. Your way may be easier than their way. R is given, I is given, V is equal to IR. Multiply both, you get V. H is equal to VIT. V you found already 100, I is 5, T is 30. Multiply all three, you will get answer as 15,000. That's all. These questions don't deserve to come in the exam itself. That was easy questions. Yeah. For which topic? People are missing here and there, and then I'll keep. No worries about that. But where you are facing difficulty in this? See, R is given. If you write the data, okay, leave this question. At least you are understanding resistance means R, current means I, time is 30 seconds. That much you are identifying. You know V is equal to IR. Ohm's law you don't know. Then you will have problem. V is equal to IR, I is given, R is given, multiply both, get V. From last 15 minutes I am screaming H is equal to VIT, VIT, VIT. VIT you have right. So if V is known, I is there, T is there, cannot you multiply three numbers? I will teach you once again, no problem in that. But is it that difficult? We are getting stuck here. That is your mistake that you have missed the class and you are coming without seeing the video.
I saw the video, sir. I couldn't understand.
But you took the notes while seeing? Then what is the meaning of seeing? See, it's not about seeing. It's about taking the notes from the video. If you have notes, you'll have the formula in your hand. If formula is there, you can substitute easily. Next question you see. Try. Give a try at least. Give a try. This question is good question. What is in power? Power is work done by time or energy by time. The formula you have now which you are using is mostly Ohm's law, which is V is equal to IR. You may use V is equal to work done per unit charge. You are using H is equal to I square RT. That's all we are using up to now. In this case, power comes additionally. So power is what? Work done by time, or we can write energy by time. Both are same only because work done only is energy. And then if you see here, energy by time, H by T, it will become I square R. So I can write power formula is equal to I square R. Not only that, you can also write I is equal to V by R. So it will become V square by R, because RR will get cancelled. Or I can write R is equal to V by I, V is equal to IR. So R is equal to V by I. So if I write V by I, it will become VI. So power formula can be I square R, power formula can be V square by R, power formula can be VI. So for power we are using three formula: VI, I square R, or IR, V square by R. And for heat we are using anything multiplied by T, that is VIT, I square RT, V square by R into T, isn't it? So these are the formula for power and these are the formula for heat energy. Anything which helps you, you can use that formula. So in this question what they are saying, electric iron consumes energy at a rate of 840 watt when heating is at maximum rate and 360 watt when heating is at minimum rate. If the voltage is 220 volt, what is the current in each case? Which formula are you going to use? Which formula are you going to use here? Power is equal to which formula? VI, common sense, very common sense. Power is known and V is known. By using P is equal to V, I cannot define I, P by V. 840 by 220 will give one answer, 360 by 220 will give another answer. That's all. For the maximum case, what will be the power? What will be the current? 840 by 220. For the minimum case, 360 by 220. Both are simple. You are getting the answer, just write in whatever way you are getting. If you write in decimal, it is better. I hope I can erase the board. Whatever I wrote the formula, I can erase that, right? So if you see the question, let us try to see what is the answer in each case. As I said, the same thing. So in one case it will become equal to 3.82 ampere. Have you got his answer? And in second case, if I put the value of minimum value and I solve it, you will get the answer as 1.64 ampere. Got the answer? You just divide and get, you will get the answer. Nothing too big to solve again. P is equal to VI, I is equal to P by V, that's all. So P by V in each case will give the answer to you. Next question. Make it fast. Next question. Always when a question comes in front of you, write the given data. Check with what formula you have in your hand and try to get the answer. For example, here you have been given the voltage, you have been given the power, you have been asked to find the power consumed if the voltage is reduced. Oh, good question. How will you solve this? I is constant, isn't it? So P is equal to VI. So from there you will find the value of I, and that I you will use and find the value of P. Simple. Yes, the same thing will happen. So first you will use P is equal to VI and find the answer for the first part, and then with that I multiplied with this V, you will get the power for the second case, isn't it? How much? 50 watts. Volts. Watts, no man. 50 watts. Power is in watts. P is equal to VI. I will become equal to P by V. 100 by 220 will give you the value of I. And multiply with 110. So it will be 50 watts. Very basic. Very, very basic question. So when they connect 220 volts, that time the power will be how much? 100 watts. So we got the value of, they have used a different method, but the answer will be same. They have used a different method, but I can assure you the answer will remain same. Oh, 25 watt they are saying. See. Okay, Yes. This can be confusing. Let us understand this question. Guys, once again. In this case, we have to take a decision whether P is equal to Vi, P is equal to I square R, or P is equal to V square by R. We have three formulas, isn't it? So, which formula has to be chosen for finding the answer? Because if we are choosing Vi and solving, we are getting a different answer, and when we are solving V square by R and doing, we are getting a different answer. So, how do you decide whether you are going to choose this formula or this formula or this formula? How will you decide? What will you choose? Why? That you are seeing in the answer given. Why did they choose this? Any idea? Why not this? Please tell me.
Sir, because it was counted in series.
They have mentioned anything like that? They have just told that there is an electric bulb which is connected across 220 volt supply, and it is giving a power of 100 watts. Now the same bulb connected across 110 volt supply will give how much power? That is the question. Right, Preetham? Nowhere it is mentioned series or parallel. Then how do you decide what formula to be used? What mistake that we did, let me tell you, what mistake we did while talking, we took current will be same for both. How is it possible? Here you have a different voltage, here you have a different voltage, then how the current will be same in both the cases? Current will not be same. What will be same? But resistance will be same of the wire. So, since the resistance is going to be same, we want to use this formula and not this formula. You can use this formula also and check, same answer will come. But what you are going to use? We are going to use V square by R. Why? Because current is not constant here. Why current is not constant? Because in each case I am using a different battery. 220 volt battery, 110 volt battery will not give same current, it will give different current. So, how can I use that? How much current came here? Suppose current came here was 100 by 220. The same current will come here. How can we say like that? We should not say like that.
Sir, then we cannot use second formula. V square R.
You can use this R, right? When you find the value of R, from that R we can find the value of I. No, it will become complicated. We can, but I have R, I have V, I can find I, and that I will use to find power. You can get the same answer. Are you getting my point? First, by using this, we will find R. The same R will be used for this circuit also. I have R, I have V. Cannot I find current? Ohm's law. I will do it for you. R will be how much? For this case, what will be the R? V square by R. So, what is that? 100 is equal to V square is 220 square. 220 square by R. So, R will become equal to how much? 220 into 220 by 100, right? So, you get 22 times 22, which is equal to 484. So, I am getting 484 ohms already given below. Now, here I have 484 ohms and I have 110 volts. So, what will be the value of current drawn? I will become equal to V by R by Ohm's law. What is V? 110. What is R? 484. I got the value of I. And now the power formula is this if I am using as you want. Power will become equal to I square. 110 by 484 square times R. What is R? 484. So, when you solve it will become 110 into 110 divided by 484 will cancel this, divided by 484. Check, you will get the same answer. Solve, you will get the same answer. Understanding? So, that also we can use if you want to use, but it is lengthy method. Need not to use that. Rather, we got the value of R. Now, R is there, V is there, directly use V square by R formula, get the answer. Why do you find I and use that? So, do not think that it will not give you, it will give the same answer to you. Lengthier method. See, concept should be clear to you. Mugging up will not help you in this. A bulb is there, connected across a 220 volt power supply, getting a power of 100 watt. So, some current would have come inside and then the power has been calculated. Now, when the voltage supply is changing, what is the value of current they are asking, so power they are asking. So, then we want to find the resistance here, same resistance will be used here in this case because R is not changing, isn't it? What is changing? Only the voltage is changing. So, in last case, why we not got the answer? Because we assume that both will have same current. It is a wrong assumption. How can both have same current if you have different powers, different voltage source? Is it clear to you? Only then I will move further. If you have problem, I will once again explain this to you. Shall I proceed further? This is how the questions will come in the examination, guys. Don't forget that. Next question. Make it fast. Electric bulb is connected to 220 volt generator. Current is 0.5 ampere. What is the power? Direct question. Direct question. Power is equal to what into what? V into I. How much is the answer? Half of 220 volt is how much? This kind of question don't expect to come. If it comes, your good luck. P is equal to Vi and they have given the value of V, they have given the value of I. Multiply both, get the answer, isn't it? Shall I go to the next question then? No need of writing any question. Just see the given data and solve and get the answer. Whatever questions we are solving, no need of writing the question and waste your time. Just write given and get the answer. Simple question. Next question fast. If they are asking in a question, calculate the rate at which the heat is developed. What are they asking? Time. Power. Because rate at which heat is developed, heat by time, isn't it? So, what is heat by time? Before some time I told you it is only power. So, when they are asking rate at which power is consumed, it means they are asking power indirectly. So, once again, write the given data. If I am a student, I will write R is equal to 8 ohms, I is equal to 15 amperes, 2 hours, 2 hours means how much minutes? 60 minutes, how much seconds? 60 seconds. And now I have been asked to find the value of P, which is equal to, what is the formula of P? Vi. I square RT is power. Only power is asked here. I can use VIT, sorry VI. VIT will not be used. VIT is energy. So I can use VI. Anything you can use, your wish. Anything you can use. If I am using VI, IR you cannot use for power. IR is for voltage. So V we can find by using this. And then you can multiply and get the value of power. Let us check how much answer is coming. 0 point. Let us check. I square R has been used here.
Sir, here I just found the power.
Yeah, power only we want to find. We want to find power only, no man. Rate at which heat is developed. Rate at which heat is developed means power only, no? Are you getting my point?
Okay, sir.
Yeah.
Sir, joule per second is actually watt, no, sir?
Yes, it's watt only. So instead of writing joule per second, you can write watt also.
Okay.
Yeah. Okay, next question, next question. See, come fast, next question. We should solve at least 20 questions today. Check it out. Write the given data first. It's a good question. It has come in the board examination. The same question has come in the board examination in past. Give a try. Make it fast, please. If you want, next week I will keep a class to teach all these things once again from the first. Miss that class also. Next class here, next Wednesday. Next Wednesday I will teach from beginning. I will not start magnetic effect, I will reteach this. Not light, man. This lesson, light. After teaching magnetic, once again I will start light only. Don't worry about that. Saturday I am not available. I am back in Chennai on Monday only. Definitely leave only. Leave. Institute itself is leave. Because Independence Day is a leave for everybody. You already have academic calendar, right? Don't you have? Check your academic calendar.
Sir, is the answer 8 by 11?
For which question?
What current is drawn from the line?
8 by 11. Maybe I don't know the answer. Let us check it. Anybody who got the answer? 8 by 11 is said by Preetham. What you are getting? 8 by 11 you are getting. Okay, let us see the question. Before we wind off for today's class, please pay attention. Last question. What they are saying, there are two lamps. Guys, last 2 minutes. Last question. There are two lamps. One is rated 100 watt and 220 volt. See, this is called as power rating. Power rating means what is the device's power and at what voltage it will operate. If power rating is 50 watt 220 volt, it means it is having a power of 50 watt and it will be operating at 220 volt. Same way, this is having 60 watt 220 volt. There are two appliances are connected in parallel. So one is these both bulbs. Are you seeing how it will look like? One bulb, another bulb. How they are connected? They are connected in parallel. And what they are asking you to find? They are asking you to find what current is drawn from the line if supply voltage is 220 volt. So they are asking what is the current drawn. It is connected to a supply of how much volt? 220 volt. And what is being asked? What is the current drawn from the supply? So first of all, I will tell you what the way of solving. Later you solve by yourself. Way of solving I will tell you. Here you have power, here you have voltage. For this bulb also you have power, you have voltage. By that, cannot you find the resistance of this bulb? And you can find R of this bulb. Can you find that? If I have the value of R1 here, if I have the value of R2 here, and if I have the value of voltage here, cannot I find the value of current? I will repeat what I have done. This bulb has P and V values. We can find resistance. This bulb has P and V values. We can find resistance. These two are in parallel. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2. We will find R equivalent. If R is known, V is known, cannot I find R? R is equal to V by I. That is the way of solving the question. This question has come in the board exam, I told you. The same question has come in the board examination also. And those who are having problem in, tell me.
Just find the I individually.
Loudly, Preetham. You are saying, can I find I individually and then add both I? That also you can do. That is also correct. What you are doing also is correct. For this bulb you will find I, for this you will find I, and then you will add them, isn't it? It will be same only. How much current is flowing here? How much current is flowing here? If you add that current only is coming here. So I am winding off today's class. with the information that on next Wednesday I will once again repeat this chapter from the beginning. Don't miss that class at least. You have already missed so many classes and not able to struggle, I mean not able to understand this chapter, you are having struggles. So, I will repeat light, that is electricity, I will do some more numericals on that day, and then we will move to magnetic effects of electric current. Bye bye, take care. You have anything in your hand now?
Yeah, sir. Ohm's law only, but the resistors are connected in very unique different ways.
Yeah, possible. They